I'm Anil Kumar sharing with you questions from my subscriber who wants to understand how to solve equations involving radicals. We also call these radicals as surds. So if square root of a number is not a whole number, in that case is not a rational number, then it is called a surd. Okay. What I've done here is taken 6 examples to give you a variety, and I hope that will help many of you to understand how to solve such equations. So we'll begin with a simple example. Square root of x minus 1 equals to 2. Squaring both sides can help solve this equation. Then we have square root of 2x minus 1 plus 3 equals to 6, where we can have a similar form by taking 3 on the right side. C, D, E, and F are kind of questions which are slightly more difficult since we have 2 radical terms in these, right? And soon you will learn how to solve these. So let's begin with the very first example, A, which is square root of x minus 1 equals to 2. Now, if we square both sides, so the first step here is to square both sides, right? So we'll square both sides. So if I square both sides, then it really becomes, let me write down here, like what we are doing here is kind of like this. Squaring this side and also the right side. Now square of a square root, you get x minus 1, right? And here you get 4. Remember one part, that once you square, you actually incorporate errors. Now this leads to errors. Why so? Well, in this particular case, it is not very clear now, but think like this. If I had minus 2 here, then minus 2 square is also 4. Do you see that on the right side? So that means something wrong could happen, right? So that gives you a hint. And therefore, you need to check for extraneous roots. So that leads to, let me write down here, extraneous roots or solutions. Is it okay? Extraneous roots. Okay, let's continue. We have x minus 1 equals to 4. So that gives us x equals to 4 plus 1, which is 5. Now, since there is a doubt, is 5 the correct solution? So we should actually check. How do you check it? To check, you need to just substitute the value back into the equation. So on the left side, we have square root of 5 minus 1, which is square root of 4, which is equals to 2, which is the right side. So we say that is the correct solution, right? So we say the answer for this is x equals to 5. Does make sense to you, right? Now I'd like you to pause the video, answer the part B yourself, following these steps which we just did. Here is my solution. So the equation given to us is square root of 2x minus 1 plus 3 equals to 6. Take it to the right side, so we get square root of 2x minus 1 equals to 6 minus 3. So we get 2x minus 1 square root as equal to 3. And now we are going to square both sides. Is it okay? Square both sides. When you do that, you get 2x minus 1 equals to 3 square, which is 9. Add 1 here. So we get 2x equals to 9 plus 1, which is 10. And x is equals to 10 divided by 2, which is again 5. It's a good idea to check. So now let us check our solution. To check the solution, we'll substitute the value which we calculated in the equation. So we'll start with the left side. We have 2 times 5, the value of x, which we just got, minus 1. We have to add 3 to this. So which is square root of 10 minus 1 plus 3, that is square root of 9 plus 3, which is 3 plus 3, which is indeed 6, and our right side. So that is the perfect solution. Is it okay? So for this, we do get solution which is x equals to 5. Okay. So I hope the basic concept is clear to you. Now we will take up part C and D, which involves slightly more steps to solve, right? So I'll take them one by one. So here is part C for us. So let me write down C here. We have square root of, let me rewrite the question, x minus 3 plus square root of x equals to 3. Now in solving such questions, what we should do is, we should take one of the radical on the other side. So we get square root of x minus 3 equals to 3 minus square root of x. And now we are going to square both sides. Now square both sides. So when you square, you will get x minus 3 here, and on the right side we get 3 minus square root x whole square. Now this could be expanded, correct? So we have x minus 3 equals to 3 square, which is 9, minus 2ab, which is 6 square root x, plus square root of x, which is equal to x, right? So here we have used a formula, which is, we know a minus b whole square is equals to a square minus 2ab plus b square. Perfect. So we have used this formula here. Still, we do have a square root, right? So we'll keep this and isolate this rather. So we'll break it on the left side now. So some extra steps required, as you can see, and we'll take all these terms to the right. So we have 9 plus x minus x plus 3. So plus minus x cancel. What we get here is 9 plus 3 as 12, and we have 6 square root x as 12. So we could divide 12 by 6 and get 2 here, and now we can actually square and get our answer, correct? So we can now square and get the answer. So if I square, I get x equals to 2 square, which is 4. So we do get a solution in this case. The idea is to check this solution, since squaring makes some calculation errors, right? So let us check the solution. So if I substitute 4 here, I get square root of 4 minus 3 plus square root of 4. That is square root of 1 plus 2, and this is 1 plus 2, which is indeed equal to, 1 plus 2, which is indeed equal to 3, and that is the right side. Is it okay? So that is how you can actually solve such equations and check the solutions. Right? So I hope that is not very difficult, and the concept is clear, right? So this is just to make you comfortable with these steps. Now let's move on to D, which is slightly tricky. Okay. Now let me take the fourth one, which is D. We need to solve the equation square root of x minus 7 equals to square root of 2 times square root of x minus 2. Now to solve such equations, we need to square both sides as we did earlier. Let me rewrite the equation. It is square root of x minus 7 equals to square root of 2 times square root of x minus 2. Now when I say square both sides, it means kind of like this. We'll square this side and we'll square the right side also. Correct? When you square square root, you get the term itself, which is x minus 7. Here square root of 2 square will be 2, and what we get here is square root of x minus 2 whole square. Now we can again apply the formula of squares. So we get here square of x minus 2ab, which is 4 square root x, plus 2 square, which is 4, right? Don't forget the term 2ab in between. Now let's open the bracket. X minus 7 equals to 2x minus 8 square root x plus 8, bringing square root term to the left. We get 8 square root x. You need to isolate this so that second time when you square, you get rid of the radical sign. Okay, so we get 2x plus 8 minus x plus 7. So you get 8 square root x as equals to 2x minus x is x, 8 plus 7 is 15. Now again, we are going to square it. So if there are two radicals as shown here in this particular example, you may have to square this twice. Perfect. So we get 64x on the left side, and we get x squared plus 30x plus square of 15, which is 225. You can isolate, taking all the terms together, we get 0 equals to x squared plus 30x minus 64x plus 225, correct? Now that becomes a quadratic equation which you can solve, correct? So let me rewrite this here. We get x squared. 30 minus 64 is minus 34x plus 225 is equal to 0. You could use the formula to calculate the value of x, or you can try factoring it using product and sum. So let me share with you how to find product and sum for big numbers. So 225, as we know, is 15 times 15, and 15 is 3 times 5, right? So 15 is 3 times 5. We are looking for two numbers whose product is 225. Of course, all of them together will give us 225. But we are looking for sum of 34 minus. That means both are negative. So 34, how do we get? I'm sorry, it is 36. 34. So 25 and 9. So now we get 5 and 5 is 25, and 9. So 25 and 9, if you add, you get 34, right? So, okay, let's do this combination. So what you could do is, if I use these two factors together, we get 25, right? So if I have minus 25 and 3 times 3 is 9, right? Then I do get minus 34. You get an idea, right? So that is kind of an easy way to figure out the factors. It's just good to share with you. So I could write this as x minus 25, that is one term, and the other one is x minus 9, and that should be equal to 0. That gives me x equals to 25 as one solution, x equals to 9 as the other possible solution. So we do get two solutions as you see here, but there is a possibility of extraneous roots. So let us check our roots. Now we can substitute on this the given equation and check. So let's check with both one by one. If I substitute 25 here, I get square root of 25 minus 7, which is how much? So let's use calculator. Okay, so we have square root of 25 minus 7, which is equals to 3 square root 2. And on the right side, we have square root of 2 times square root of 25 minus 2, which is square root of 2. This is 5 minus 2, which is also 3 square root 2, right? So that is perfect. So 5 works, right? So this 25 works. So we have x equals to 25 as one of the solutions. Now let me try 9 also. So we have, now let's try 9. So we have square root of 9 minus 7, which is square root of 2. If I try on this side, we have square root of 2 times square root of 9 minus 2, which is square root of 2 times 3 minus 2, which is square root of 2. So that also works, right? So 9 is also a possible solution. So we get two solutions for this particular equation. Let me write on our answer, which is x equals to 25 and x equals to 9. Is that clear? So this time there are no extraneous roots. It's perfectly fine. Now let's take up the next example, which is square root of 2x minus 3 plus x plus 2 equals to 3. So let me rewrite this question. We have square root of 2x minus 3 plus square root of x plus 2 equals to 3. I'd like you to pause the video, copy the question, solve, and then look into my solution, since we have already done similar kinds, right? Let's rearrange. So the steps are very clear. You have to isolate one of these first. So we get 3 minus square root of x plus 2. And now we'll square both sides. Let me show it here with the different ink. So when you square both sides, you get rid of the radical sign. That is the purpose. You also incorporate errors. Don't forget that. So we get 3 square is 9 minus 2 times 3 is 6. Square root of x plus 2. And square of this will be x plus 2. So we can simplify this and then we'll isolate that part. So 9, so we have x, 9 plus 2 is 11, plus 11 minus 6 square root x plus 2. Bringing this to the right side gives us 6 square root x plus 2 equals to x plus 11 minus 2x plus 3. 6 square root x plus 2 is equal to, so that is minus x. And we have 11 plus 3 as plus 14. Correct. So now we can again square both sides and then simplify, right? That's the whole idea. So we'll square both sides. So when you do that, 6 square is 36 times x plus 2. On the right side, we get square of this term, which is x squared minus 2ab, so 28x. And then we have 14 square. So we have 14 square equals to 196. So that gives me plus 196. Now we have to bring all the terms together once again. So 0 equals to x squared minus 28x plus 196. Take away 36x and then take away 72, right? So we'll bring this to the right side. We have a quadratic equation to solve. We have x squared minus 28 and minus 36. Let's do this, add them. 28 plus 36 is 64. So we get minus 64. The 196 take away 72 gives us 124. So we get plus 124 equals to 0, correct? So we're taking care of x squared. These two terms combine to give us a bigger number, minus 64. That gives a smaller positive number, 124, right? Now at this stage, as we did last time, you could actually do quadratic formula, or you could again try factor them. So let's again try our trick of factoring. So we'll start with 124, and 124 could be divided by 2, for example, right? So 62 and could be divided by 2, which is 31, correct? So we need 64 by adding, so this is 32 plus 2. That makes sense, right? So if I multiply these two terms, I get 62, and 62 plus 2 is 64, both negative. That makes sense. So we could write this as, let me rewrite this, as, I hope you find this very useful, right? So it's easy, right? Minus 62 times x minus 2. Do you see that? It's so simple. So split 60, I mean this is x, I'm sorry. So 64x, split it into minus 62 and minus 2 to get your answer, right? So when you multiply, you do get 124. So we get x equals to 62, as one of the answers and x equals to 2 as the other answer. Correct? Now we need to verify whether it really works or not. So let's check. Left side. So let's check for x equals to 62 first. So if I do square root of 2 times 62 minus 3 plus square root of 62 plus 2, what do I get? So let's calculate. It's easy, right? Square root of 2 times 62 minus 3 equals to 11, and then we'll add 8 to it, right? So if I, let me write down here. So this is actually 11, right? Plus 64 is 8, and that gives you 19. But we are looking for 3, correct? We are looking for 3. So that is not a solution. It doesn't work. You see that? Now let's try the other one, which is 2. So if I try 2, what do I get? I get square root of 2 times 2 minus 3 plus square root of 2 plus 2. So this is 4 minus 3, which is 1, and this is square root of 4. And we do get 1 plus 2 equals to 3. So that works, correct? So we have only one solution, which is x is equals to 2. 62 did not work for us. Do you see that? Now that is always possible since the squaring causes error. So we have one solution here, which is our answer, x equals to 2. Correct? So you see that squaring causes error, and therefore we need to check our solution, and we found that one of the solution is not correct. Now let's do the last question now. I'd like you to pause the video, copy this question, solve, and then check my solution. Now here is the last question. I hope the concepts are absolutely clear and you are in a position to do this. Let's rewrite. We have square root of x plus 1 equal to 3 over square root of x minus 1 minus square root of x minus 1. Now we can take common denominator, then we get rid of this term. So let's do this. So we get 3 minus square root of x minus 1 a whole square divided by square root of x minus 1 equals to square root of x plus 1. Now we can cross multiply, right? So we get square root of x plus 1 times square root of x minus 1 equals to 3 minus within bracket x minus 1. So this question is slightly different from the ones which we have done, but it has similar concepts. Is that okay? Now we can actually multiply these two terms, a plus b times a minus b. We get x squared minus 1 within square root. And here we are left with 3 minus x plus 1. So we could, let me go one more step. X squared minus 1 equals to minus x and plus 4. Right. Now we have a radicals involved, so we'll square both sides, correct? So we'll square both sides. So if we square both sides, we get x squared minus 1 on the left side. Here square is x squared minus 2ab, 8x plus 16. So we do have a quadratic equation looking at, but these x squares cancel out. Bringing terms together, we get 0 equals to, let me rewrite this, x squared minus 8x plus 16. Taking this to the right side gives you minus x squared plus 1. So we get 0 equals to x squared cancel. So we have minus 8x, and 16 plus 1 is 17. So that gives you 8x equals to 17, and x is equals to 17 over 8. So we get a solution which is 17 over 8. Now the idea is we should actually check our solution, right? So let's check the solution. We'll substitute 17 over 8 here on the left side. So what we get here is square root of 17 over 8 plus 1. So let's use calculator. So we'll do square root of, I'll do 1 plus 17 divided by 8. So what I get here is equal to 5 square root 2 over 4. On the right side, let me do again. We have 3 divided by square root of, I'll put it in brackets, 17 divided by 8 minus 1. Minus 1. So the first part here is 2 square root 2 minus, now I'll do the second term here, which is square root of, so within bracket, I'll do 17 divided by 8 minus 1 equals to, it is 3 square root 2 over 4. So let's combine these terms. Is it okay? So we have 2 square root 2, take away 3 square root 2 divided by, let's divide this by 4. And what do we get? We get equals to 5 square root 2 over 4. Do you see both are equal? Right. So the left side equals to right side. So this solution works. Perfect. So therefore, we know that the answer is x equals to 17 over 8. Right. So that becomes the solution of the given question. So I hope you enjoyed this journey of learning how we can solve equations involving radical signs. Feel free to write your comments, share your views, and let me thank all my viewers and subscribers who are posting excellent questions. Thank you and all the best.